In this video, we're going to have an introduction to functions of several variables where we could have an x and a y. Some of them may have an x, y, and z. We're also going to look at what's called a partial derivative, and that is investigating the rate of change in a function of several variables with respect to one of the two or three variables in the function. But in the first couple of examples, what we're going to do is we're going to just get used to seeing functions of several variables, plugging in various numbers, learn how to calculate, and then we'll move on to the partial derivatives. And for those, we're going to do some derivatives and also plug numbers into those derivatives and try to give it some context. This first function is a function of two variables, x and y. Whenever you're given a function like f of 0, 1, just match up your first number with x, your second number with y, and you can plug these directly in. For example, we have 4 minus 0 squared. It's very intuitive. Just instead of only plugging in one value, you've got several. And then we're going to plug a 1 in for the y, square that up. Be careful to use order of operations. 0 squared minus 4 times 1 squared. And this actually comes out to 0, doesn't it? All right, let's do another one. F of 2, 4. We're going to plug a 2 in for x and a 4 in for y. So that is 4 minus 2 squared minus 4 times 4 squared. Just make sure that 2 goes in for x, 4 goes in for y. You can put these in a calculator all at once because those do know the order of operations. If you just want to hack away at it a little bit at a time, that's totally appropriate too. 4 squared, 16. So that's going to give us 4 minus 4 minus 64 for a grand total of negative 64. A few of them in your homework assignment will, instead of having a number for every variable, sometimes the variable is left open, and maybe the other one or other two variables do have a numerical substitution. For example, if you were to see something like f of x0, you hold the x open and plug the 0 in for y. So that's going to be 4 minus x squared. I just didn't want you to be alarmed if you saw one without a numerical substitution. That is totally appropriate. You just leave the letter alone instead of plugging a number in. Okay, so that is 4 minus x squared. On the end, 0 squared is 0, times 4 is still 0. And so that leaves us with 4 minus x squared. And that's totally appropriate. We didn't have a number for x, so x stays open. Let's do a 3-variable function. This function has variables x, y, and z, specifically defined as the square root of y plus z, all divided by x. Let's find the value of f of 1, 3, 6. Now, just like the last example, you're going to respectively plug in a 1 for x, 3 for y, 6 for z. Just be careful along the way when you're making those substitutions. Square root, the y coordinate and the z coordinate are 3 and 6, so that's 3 plus 6 under here, all divided by the x coordinate 1. Well, that's going to make it nice. All right, so we've got square root of 9 all over 1, which is 3. Let's try f of 9, 10, and negative 3. Okay, so that's square root. Okay, the y plus the z is 10 plus a negative 3. All over the x value of 9. Well, that gives us what? Square root of 7 all over 9. And since 7 is prime, it's not going to have a very friendly value. It is going to be roughly 2.5 maybe. It's a little more than 2, a little less than 3, but it will be in never-ending decimal. So we'll just leave it in radical form of square root of 7 all over 9. For a third example, let's look at, and it's actually a familiar formula. It is the amount in an account that has compounding continuous money, where P is the initial investment or the principal, R is your interest rate in decimal form, and T is the number of years that the account is active. So finding A of 400, 0.10, and 6 is like finding the amount at the end of 6 years if 400 is the initial investment at 10% interest. Well, let's plug this in. This will be equal to 400 e to the 0.10 times 6. And we're just going to round this to the nearest penny. Let me grab my calculator. All right, so 400 times e to the 0.10 times 6, I get 728.85. Okay, let me give you a little bit to work on this one. If you want to pause the video after I get the numbers written in, see if you can calculate this on your own, that would be great. Now this will be the ending amount if 1,700 is invested at 11% interest, compounded continuously for 20 years. All right, so let's see, 1,700 E, the exponent is 0.11 times 20. We've got to keep all that grouped together. And let's calculate. 1,700 E, 0.11 times 20. I get $15,342.52. In this example, let's look at a Cobb-Douglas production formula. We have f of xy equals 100 x to the 0.75 power times y to the 0.25 power. We're going to estimate the production level when x equals 1,400 and y equals 1,000. So those are our two substitutions. We have f of 1,400, comma 1,000. Okay, so that's going to give us 100 x, which is 1,400, almost forgot to do the substitution, to the 0.75 times 1,000 to the 0.25 almost run out of room there too. Okay, now on your calculator, you're going to want to use the exponent button very carefully, just in order to put, let's see, we've got 100. Okay, 1,400 raised to the 0.75 power. And let's see, let's carry this to about 3 decimal places until the end. The more decimal places you keep along the way, the more accurate your final answer will be. I've got 228.874. Now, if you're careful, you can type this in all the way. You don't have to do it a little bit at a time. 1,000 to the 0.25. I get 5.623. 5.623. Okay, now with it rounded, and our homework is asking us to round this one to the nearest whole number. 100 times 228.874 times 5.623 is 128,696. Okay, now let me go back and I'm going to do this calculation. I'm going to do it in blue. If I don't round along the way, and this is how you can compare and contrast the values that you will get. If I don't round through the problem, 100 times 1,400 raised to the 0.75. Make sure you arrow out of that exponent before you do times 1,000 raised to the 0.25. Now, if I don't round throughout, then I get a more accurate answer of 128,705. That's the one I would trust the most because there hasn't been any rounding to lose accuracy.